Alright guys, this is the last video for this section on 5.4, and it's the very last problem in the very last section. This is the problem where this is going to take the longest. This is kind of the oddball out of all of them, and it's going to take the most amount of work. So if we look at it, we're going to be given a function that has sine and cosine in it. And so this is the function that's given. And we want to rewrite this so it's in this form. So it's just in terms of just sine. Well, the first thing we're going to do is we're basically going to use the sum formula for the sine. So this a, you can see I've already expanded it. I have that a on the outside. And when I use the sum formula for this bx plus c, this is where I get this whole mess on the inside. All right. So that's going to be your first step. And when you do that, you see you have sines and cosines, just like you had sines and cosines on what you started. All right, and then the main thing is, when we have this whole thing written out, there's three things we want to solve for, the three letters. I want to get what A is, what B is, and what C is. The first thing we can solve for is B. That's just the coefficient of X. And that's kind of given right here. Since this is just x, and these are going to be the same for both, well, that's assuming that b is 1. So right away off the bat, I'll put this in a different color, we're going to assume that b is 1. All right? And then what I'm going to do is, in a different color, I'm just going to distribute a to the two terms on the inside. So we're going to have a times the sine. Now, I've already stated that b has to be 1, so I'm just going to leave it as sine of x, okay, times cosine of c, plus cosine. Again, we're going to say b is 1, so we'll say cosine of x. Whoops, I forgot the a. All right, distribute that a. And then times the sine of c. All right. Now, if you look, we want to set this whole thing equal to this right here. All right, so let me show you what we're going to do. So we have space moving left to right. So I want to set this equal to, as I said, this part right here. So if I set this equal to 2 sine of x plus 5 cosine of x, all right, then we'll be able to solve for, what is it? It looks like a and c. All right. So, all right, let's see what's similar. Where we have this sine of x, I'm going to set that equal to the term that has sine of x on the left side, this whole mess, which is really this. So I'm going to set those equal to each other. Now, to make this so it's a little bit cleaner, I'm just going to switch. I'm going to move this cosine of c here. So I'm going to have a times cosine of c times the sine of x. And I want to set it equal to this, because that has a sine of x, so it's 2 sine of x. All right. Okay, then what I can see is, since these are both sine of x, this implies that a times the cosine of c has to equal this, the 2. So I'm going to write that a times cosine of c has to equal 2. And then if I were to get this cosine of c by itself, I would divide both sides by a. So I would have cosine of c equals 2 over a. And you can see how ugly this gets. All right, then I want to move it down so we have space. And what's going to wind up happening for these problems is you're going to draw a right triangle. So when I draw a right triangle, all right, cosine is what? Adjacent over hypotenuse. So if I say this is, let's say that's angle C, adjacent is this, which is 2, and the A is the hypotenuse. Okay? Now, I don't know what the opposite side is, but when I work with the other term, I'm going to be able to figure that out. All right? So follow me here. Okay, then this next part, let's see if I can use a different color here. All right, so if I use yellow. Now, if I go back up, this A cosine of x times sine of c, I'm going to set it equal to cosine of x because they both have a cosine of x that are common with each other. All right, so let's see if I have space. I'm going to move this to the right. So everything that's in yellow, I'm going to set equal to each other. So I'm going to have A times cosine of x times sine of c equals, let's move this over, and I'm just going to set it equal to that 5 cosine of x. All right. So then you kind of see right here, these cosines of x, it's almost like they cancel each other out. So you're just going to be left with A times the sine of c is going to equal 5. All right, these cosines of x will kind of cancel each other out. So we'll have A times the sine of c equals 5. And this is going to give us that other right triangle. So then if we get sine by itself, we'll divide by A. We'll have sine of c equals 5 over A. All right. So now when we set up this right triangle, what we were able to figure out, okay, if we look at both of these, see how A, for both of these equations, A is the hypotenuse. Now in this, I can see that 5, since it's sine, this is going to be the opposite side, so I'm just going to put that in there. So now we have that right triangle, and I'll be able to figure out A and C by using SOHCAHTOA or using Pythagorean's formula. Now A, I can figure that out by just using Pythagorean's formula, right? If I can just say 2 squared plus 5 squared is going to equal this, A squared. So let's see here, 2 squared plus 5 squared is going to give us 29. Take the square root. So A is the square root of 29. For C, you would use your calculator. This is what the opposite side. This is the adjacent side. So we could say, we're going to use tangent. So we could say tangent of C equals 5 over 2. Now this you would just have to put in your calculator. You would put in inverse tangent of 5 over 2. And when you do that, you would get this to be, let's leave it in degrees, you would get 68.2 degrees. All right. Whoops. So this is a mess, this problem right here. This is definitely a problem that I would look over again, stop it, rewind. There's going to be one problem, I believe, on the homework on this. So if you have questions, on the Google Meet, we'll go over it. But just to sum this up, our answer to this problem, we got A, B, and C. So here's the answer. It's just y equals, we figured out A was square root of 29. And then it's saying you have sine of bx plus c. So you would have sine of, well, b is 1, so we say x. And then c we figured out is at 68.2 degrees. This is what the final answer would be. All right, so this is definitely the hardest one. You can see it's the longest video right here. We're over 9 minutes. But just take your time with this. And again, if you have questions, we'll go over it on the Google Meet on Monday.